All right, why don't we get started? So, any questions about anything so far? Anything we did? Any of the assignments?
I actually have a question.
What's up?
I was doing one of the assignments
Which one?
called for me returning true or false.
Which assignment exactly is this?
Good question. Well, anyway, it told me to return true or false,
Okay.
and it worked for like 2 runs,
Mm-hmm.
but then it stopped working.
Okay, I'm gonna have to look at it. But do you have any questions about how something should return true or false? Do you know how to do that?
Well, I know how to do that, but it stopped printing true or false.
Okay, I have to look at it. All right, so we are done with week 6, which is functions, and today we're doing week 7, and week 7 talks about recursion, sorting, and coding bat. And let's go over that stuff. So first of all, just a quick review. Maybe I should just go to the previous week so I can see what I told you and go from there. So let me download this real quick, and so we can have a look at it real. And I will throw this inside idle just so we can revisit real quick what I told you last time. So last time we talked about functions, right? Whether you say function, module, procedure, method, pretty much the same thing. This was your basic example of a function. This is how you define a function with the def keyword, and then it's the function name and then parentheses. You could have something inside of the parentheses, and those will be the parameters of the function. But since this is the simplest function possible, no parameters, does not return a value, and the only thing that it does is it just prints a couple of lines of code. Okay. This is the beginning of your function body. This is the end of the function body, right? Everything in the function needs to be indented exactly the same. If you have anything off like this, it's not going to work. And the name of the function is stars, and this is me calling function stars. Okay, as soon as you call the function, you jump to the function body and execute everything that's in it. Every time you call the function is every time you're going to execute everything that is inside of the function, right? So I call the function 3 times here. These 4 lines of code are going to be executed 3 times. The next example I gave was a function which takes a parameter. The parameter is the variable in between the parentheses, right? And the function name is showNum. What we're going to do is we're going to show that number, and that's basically it. And then if you wanted to call this function, you do it like so, right? So this is how you call a function that takes a value. That value that it takes is called an argument. As soon as you call the function here, then you're passing this value 10 into the function, and the argument or the parameter num becomes equal to the argument. So as soon as you call the function, num here becomes equal to 10, and then I'm going to show you num. Okay. You can send different numbers. You can also send variables into the function, right? So if you're sending a variable as an argument, you're actually sending the value of the variable. Okay. So whether I put a here or I put 99 here, it's still exactly the same thing. It works exactly the same. Okay, so this is calling a function with an argument. What I did was I also gave you an example that, let's say for example here I have a variable a, right, and I'm showing you the value of a here, and then when I passed right? So we'll show a is equal to 99 here. Then I pass the variable a into the function, and then in the function I say a is equal to 100. Okay, so if I do print a here, what does this show? Does it show 100 or 99? Huh? So the question again is, let me expand this thing a little bit so you can hopefully see both of them. So I have a variable a here, which is equal to 99. I'll show you the a that it's equal to 99 here. Then I pass a into the function, and then in the function call, so this is going to be equal to 99, but inside of the function definition, I say that a is equal to 100. So my question to you is, when I do another print, wherever that is, I don't have it. So if I do another print right here, if I do print a, what is going to be the value of a here? Huh? It'll be 100? Okay, let's run it. A is 99. Okay? Why is that? Because this variable a is different than this variable a. Okay, this variable a, I have basically defined it inside of this function, which means that it belongs only to this function. So even though this is called a, and this is also called a, they're actually referring to different places in memory. So if you changed this a here, that does not affect this a here. Okay, because they're two different variables in two different places in memory. This one here is not visible outside of the function because I have defined it inside of the function. Okay, so this is known as a local variable. Okay, what is a local variable? Local variable is a variable that is defined inside of a function, inside of an if, inside of a while loop, right? Inside of a block of code somewhere, and it is not visible and usable outside of that block of code. That is the meaning of a local variable. Okay, where a variable can be used is called a scope, right? That's the scope. Scope is where can it be used. So where is the scope of this variable a? What is the scope for this variable? The scope of a variable is the section, the segment of code where it was defined. So since I have defined this inside of the show num function, that means the scope, or where it can be visible, or it can be used, or it can be changed for this variable is this function. Okay? In fact, if I have some kind of a variable here, for example, b, right, and I tried to use that variable b outside, like right here, then you will get an error. And there's the error. The error is b is not defined. Well, I defined it, but I defined it inside of this function, which means that this is a local variable to the show num function, which means that the scope for this variable, or where it can be used, where it can be seen, where it can be shown, changed, is only this function. Okay? So that's the example that I had last time. Right? So you cannot, if you define a variable inside of a function, you can only use it and change it and see it inside of that function. Okay? That was the example. Then the other thing that I showed. Then the next thing that I showed was a function returning a value. So here I am defining a function called returned one, parentheses, right? And the only thing that this is going to do is it's going to say return 1. Okay? And then when I call the function right here, I showed you that this doesn't show anything. Right? So if I call the function here, we jump to the function definition, we go to the return. As soon as you get to the return, you exit the function, bringing back this value 1 where the function was called. So it will just literally bring the value 1 right in there. And can you see this 1? No, because you need to see it. If you want to see it, you need to put it in a print. Okay? And that was the next thing that I did. Which was to call the function from inside of a print, right? So as soon as I call the return 1 from inside of a print, you jump to the function definition, you get to the return, and then you bring back this 1 right where the function was called, and then basically the function call is being replaced with the value of 1, and then you're going to see the 1 because it's inside of a print. Another thing that you can do where the function that returns a value is you can make some kind of a variable equal to that function call, and then when it goes and executes the whatever's inside of the definition, right, it will bring back the 1 right where it was called, right? This is going to be a 1, return value is going to be equal to 1, and then return value, you're going to be showing the 1 in there. Okay? Any questions about this stuff? Okay. So then the next thing that I showed you was that if you have a return in your function, when you have a return in your function and there is some kind of a code or whatever, something after that, it will not happen, right? So I have a print in here. This high, you will never see the high. Why? Because the function will exit as soon as it gets to the return. This was the same thing that happens when you have a loop and you hit a break, right? Whatever's underneath the break doesn't happen. So that's the same exact effect when you have a function. You could have a function that is not supposed to return anything. So if I went and I just did return right here, what's going to happen is, let's say I call the function, I go to my function definition, I start executing it, and it will hit the return. As soon as it gets to that point, it exits. So if I have a return here, you're never going to get to see these stars. Okay? So be careful where you have a return, because that's going to exit the function. Sometimes you can use the return to bring back a value or a list or whatever. Sometimes you can use the return just as a break to exit the function. Okay? So that was a function returning a value. Then the next thing that I did was I took it one step further and I said, okay, well, why don't we have a function that has 2 parameters, right? Those 2 variables are my parameters, right? And I showed you that, well, I'm going to ask the user to enter 2 values. Then I'm going to send those 2 values as arguments into the function, right? So I'm sending the A and the B into the function. This one is going to be equal to A. This one is going to be equal to B. I'm adding A plus B, and then I'm returning A plus B. So the sum of A plus B will be returned right where this thing was called, and that's the purpose of the function. And another way to do this was how I showed you here, right? I can have some kind of a variable is equal to the function call, and then I can show you the variable or whatever that function returns inside of a print. The next thing that I did was I showed you, and I guess that was a hint for one of the assignments, was basically how you can have one function call another function, right? So I have one function here, this is my hello, then I have another function here, that's my other one, and in this one I call this one, right? And the way I tricked you last time was I said, okay, well, let me take this out, right? And then I try to run the code and you never got to see this. Right? And I asked you, well, what's happening? And then you thought about it, and you told me that, well, you never called the main, right? So I need to call the main to jump to the main definition, which is where I'm going to call the next function, and then I'm going to jump to the definition of that one. But if I never call my main, right, I will never be able to call this function hello, because that function is only called inside here, right? So this was just an example of one function calling another function. And yeah, there's some more examples in there. And then I had one where a function can return true or false, right? I showed you how you can see that it returns true or false if it's positive, right? One thing I didn't show you was that I can actually use that inside of ifs, right? So let's say I'm going to go in here and I'm going to say, okay, well, if is pos, and then let's say some kind of a variable, I'll make the variable right here. D is equal to 1. Okay, if is pos D, then I can say print the number D is positive. Okay, and then I can do else, or let's do L if not is, well, let's do not is pos d, and then I say print, let me just copy that whole thing, is negative. All right, let's see if that works. So run it. All right, so the number 1 is positive. All right, so what happens is I execute the function call. I go in there, so d is equal to 1. Is 1 bigger than 0? Yes, it is. Return true. And then I come back and I bring back the value true right here. Okay, so if it is true, which it is, then show something. Okay, and this is one way to do it. Another way to do it is I could say equals equals true. That's one way to do it, but if you want to have your code a little cleaner, right, you can just do it this way. And let's make it a negative. See if it works for the other one. Right, there you go. So that's a negative. So this is not, it is not equal to, this is not positive, right? So then you're showing the negative. Okay, so this is examples of a function returning a value inside of an if. Okay, you can do that inside of a while if you want to. All right, and then some more examples in there for the assignments. Any questions about any of this stuff? We're good? All right, so what I want to show you now is one more thing, and that is how you can have a function call itself a bunch of times. Okay, and this is actually one of the more confusing things in programming, in my opinion. And I'll also show you a BubbleSort so that you can use that with the coding bat. Okay, so I am going to just wipe all this stuff out, all right, because it's pretty much the same as last time. Okay, so let's say I have, and by the way, just a quick reminder, remember that you can have one function calling another function. In fact, let me just leave that piece. All right, so this was an example of a function calling another function, and I will leave this too, because that was a new one that I gave today. All right, so in here, what the hell, I'll erase all this. Okay, so you have an example of one function calling another function. Okay, in fact, let's do this. Now I'm going to show you how a function can call itself. So just a quick refresher. We're going to use this similar to how we're going to use the loop. So just a quick review for loops, right? Loops. You can have a for I in range from 0 to 3 steps of 1, and I can say print I equals I. Yes? And if I run this thing, what is it going to show me? 0, 1, 2? Hopefully. 0, 1, 2. Yeah? I can do the same thing with a while loop. I can say, okay, well, I is equal to 0, while I is less than 3, print I equals I, and then I say I plus equals 1. Same thing. So what is this going to show me? 0, 1, 2. Yes? All right. Well, there's another way to do this, and that is by having a function call itself repeatedly. So here it goes. This is your new stuff. So this is known as recursion. And what is recursion? It is a function calling itself until some condition is met. Okay? So first of all, let's say I do this. I say, well, first of all, let's run it. All right? So you can see that it works, right? 0, 1, 2. Now the next one is, I'm going to do this. I'm going to say def recursive, and I'm going to give it some kind of a value. And then in here, I'm going to say recursive num equals num, and I'm going to say num is equal to num plus 1, right? And then if I call the function one time, I just do recursive 0, yeah? And I run this thing, recursive num equals 0, right? Which is what we've learned, nothing new. Okay, but now what I'm going to do is in here, I'm going to say, okay, well, do recursive, and I'm going to move this here. Okay, I don't know if that's going to work. I think so. Try it again.
Would you find that as num plus equal 1?
You can do that too, yeah. You can do Control C. Okay, so yeah, I can do num plus equals 1 also. Alright. Alright. So the bottom line is, no, I guess it doesn't like plus equals. So it has to be num is equal to num plus 1. We found out. Okay? But what happens is, let me pause it or kill it. C. Control C. Okay. So what happens is I call the function given in a 0. I show you the 0. Then it calls itself, but this time it calls itself with 1 more than 0. Right? So then it calls itself with num is equal to num plus 1, which is 0 is equal to 0. I mean, num is equal to 0 plus 1. So now it's 1. We're calling it again. And then this time it shows the 1. Then we're going in there. We're increasing that by 1. Then it goes to 2, and then so on and so on and so on. Right? Which is what happens here. Okay? So what I'm going to do is I'm going to tell this thing, and by the way, I can take this out of here. Let's move it out. Now I'll leave it there. Okay, so what I'm going to do though now is I want this thing to stop at 3. All right? In fact, I want it to stop at 2. Okay? So what I'm going to do is I'm going to add a condition here. And I'm going to tell it, okay, well, if my num is less than 2, then call yourself. Might even have to be less than 1. Okay? So only if it's less than 2, call yourself with this plus 1. In fact, what I'm going to do is I will move this out. So I'm going to take this, I'm going to put num here, and I'm going to put this right there. Okay? So now what's going to happen? I'm calling the function with 0. We're sending a 0. I show you the 0. Then it goes to 1. Is 1 less than 2? Yeah. Call yourself with 1. Go back. Now this is a 1. I show you the 1. 1 plus 1 is 2. Is 2 less than 2? No, it isn't, so it's going to stop calling itself. Alright, so the way I have it, I think we should have it as less than 3. Alright, so it goes up to 2. And if I run this thing, there you go. Easy, right? You think so? For now? Okay. All right. So now let me do this. Now that you think this is easy, here's what I'm going to do. I want to grab this thing here. I'm going to cut it, and I'm going to throw it right here. Okay. Now tell me what is this going to show me? When I call the function with a 0, what is it going to show me? I like to play this game with students because, come on, give me a guess. Huh? Nothing? Okay, we have a nothing. We have an error. What else? Same. Okay, you gotta make a guess too.
Nothing.
Okay, we have 2 nothings. We have the same, and we have an error. Okay, all of you got it wrong. Okay. And I like to play this game because I'll have like a bunch of students in the classroom and I'll pick around and nobody gets it because it's confusing. Okay, now let me run it and blow your mind. What? Yeah, why is it going in reverse?
Because that's good to print after you calculate.
Uh-huh.
What?
It is wide, but it's hard to visualize. Okay, so that's what I'm saying. It is confusing to to do this. So let me show you what's happening. So first of all, you understood the first version, right? This one was easy enough, right? You got how this worked. Right, 0, 1, 2, that makes sense, right? We call it with a 0, we show the 0, go to 1. Is it less than 3? Yes. Increase yourself by 1. Well, send the 1 over, show the 1. Now it's a 2. Is 2 less than 3? Yes. Call yourself at 2, right? Show the 2. Now it's a 3. 3 is not less than 3, stops calling. That's it. Okay. Now, what I'm going to do is, again, I'm going to grab this, I'm going to move it here. And what I have to do is, the best thing for me to do it is just, let me just grab this thing and throw it in Excel. And not a new one. So let me erase this crap. Okay, so here's what I'm going to do. I'm going to get this. Yes.
So is this recursions respond to code line, or in this case it doesn't?
Sure it does. Yeah, this works exactly like all your other programs, line by line. It goes from top to bottom, top to bottom, top to bottom. We haven't, same rules apply. So let's visualize what happens. So you already said you understand this piece, right? We got that. So now let's try to figure out why it's behaving this way. Why it's doing the 3, 2, 1. Okay, so what I'm going to do is, let me try to see if I can move this here. I don't think that's gonna work. No. Okay, undo it. Alright. Okay, so I am going to grab this thing here. I'm gonna take a picture of it. And I'm going to put it inside here somewhere. Eesh, big picture. I didn't want that big of a picture, but okay. So there you go. So let's see what happens. And actually, let me do it another way. Let me erase this. I am going to have this first. I'm going to cut this, throw it there. All right. And then I'm going to have the other one here. There. Okay. All right. So what happens with the initial call? Let's see. I'm going to resize this a little more. Okay. So insert. Where are my shapes? Shapes. There's an arrow. All right. So I call initially with a 0. Yes? So this is when num is equal to 0. You agree? Okay. Num is equal to num plus 1, so it goes to 1. And then, let me move this down a little bit. There you go. All right. So at this point, num goes to 1, right? Is 1 less than 3? Yes, it is. Now call yourself with 1. Okay? So basically, what we're doing here at this line is we're saying recursive num1. And let's see if that works. Okay, I'm going to grab my arrow. Shape. There you go. Okay, so at this point right here, I'm calling this thing with a 1. Yes? You agree with this? Okay, so num is equal to 1 here. And right, then it's going to go num is equal to 1 plus 1, so it's a 2. Is 2 less than 3? Yes, it is. So now call yourself with a 2, right? So let me try to copy both of them. Copy. And I just clicked, I press command to select both of them, and then I copy both of them. Alright, so this one was num is equal to 1. Let me put it on top. This one was num is equal to 0. Let me put it here. Okay, so now I'm calling this thing with 1 plus 1. Wrong arrow. Right there. Okay, so at that point, what is the value of num? 2. Alright, num is equal to 2. Okay, I've done better jobs drawing these, but this time it's not working for me. Okay, so I start calling it with a 0, right? Then it goes to 1. Then I call this thing with a 1, right? Now it's a 1. Then I call it with a 2. Now it's a 2. And at this point, when we get to this one now, this last one, right? So num is 2, right? So num is equal to 2 plus 1, so it's 3 now. Is 3 less than 3? No. And we're no longer getting into the if, so we're done calling. And then we get to the print. Okay, so that is the first print that I'm going to show. Print recursive num equals what value did we say? 2. No, 3. Right? Because num was 2 here. 2 is equal to, num is equal to 2 plus 1, so it's a 3. Recursive num 3. Yes? Okay, now let me try to pick a different color. Or whatever. Who cares about the color? Let's go with here. Alright, so as soon as I get to the end of the function, let's say this is my end of the function, then I'm going to return right after I was called. Let me go different color. Let's go orange. Okay? So I went from this call to this. I executed whatever's in it. I showed you the first print. I got to the end of this function. As soon as I get to the end of the function, I'm returning back to right after I was called. Right? So I'm returning back right after I was called. And then what's the next thing that's left in this function? Well, it's this print. So now the next thing that I'm going to show you is the next print over. And what do we say that num is here? Num here was 1. Right? So since it was 1, we had num is equal to 1 plus 1, which was the 2, how we got this one. So what am I going to show here? I'm going to show the 2. Okay, so that's the second thing that I'm showing. Okay? And then as soon as I get to the end of this function, then the next thing I'm going to do is I'm going to return back from there to where I was called originally, which was right here. And what was num here? Num was 0. Or num is equal to 0 plus 1, which was the 1. So the last thing that I'm going to get is the 1 here. Got it? Any questions? It's tricky. So that's recursion. And it's hard to visualize something like this because we don't think recursively. It's hard to put all that stuff in your head. And you might ask yourself, why do we care about recursion? Is it any faster than a loop? No. In fact, if you have the more recursive calls you have, the way functions are called in memory, you have a stack. It's called the stack, which is part of the processor. Which is every time you call a function, you push it on the stack, right? And the stack it's a finite stack, so you can only call functions so many times, and maybe after 10,000 or whatever, it's going to run out of stack space and it's going to crash. So you can't really have a recursion. So number one, it's not as fast. Number two, it cannot happen as many times as a loop. So what do we want a recursion for? Well, there's some problems that are easier solved with recursive thinking than they are with a loop. One example is the merge sort. Right? So what I'm going to show you today is how to sort things. And the algorithm that I'm going to show you is called the BubbleSort. Right? So BubbleSort that I'm going to show you is actually the easiest to understand sorting algorithm, but it's also the slowest one. Right? So let me do BubbleSort. Okay, so if I do BubbleSort, this is what a BubbleSort looks like. So you have a bunch of numbers. They're in whatever order initially, and the algorithm is this. You're going to look at two numbers at a time. You're going to compare left to right. If the left is bigger than the right, you're going to swap their values. Then you go to the next two numbers. Is this one bigger than this one? Yes, it is. Swap their values. You go one next, or the next two. Is this one bigger than this one? Nope. Just leave them as is. Go to the next one. Is 8 bigger than 7? Yep. Swap their values. Go one down. Now we're going to compare 8 to 2. Is 8 bigger than 2? Yep. Swap their values. Then we're going to go to the last two, right? And then we're going to compare 8 to 4. Is 8 bigger than 4? Yep. Swap their values. So what happened was we grabbed the biggest number and we moved it all the way to the right. Or the biggest value bubbled up to the top. Okay? Then we're going to go back to the beginning. We're going to repeat the process all over again. And when we're done with the second pass, what's going to happen is we're going to get the second biggest number, which is the 7, and we're going to move it next to the 8. Then we're going to go back all the way to the beginning and repeat that and over and over and over. And if we repeat that as many times as their numbers, approximately, you're going to end up sorting the whole thing, right? Another way to visualize this is they have another picture somewhere in there. There it is. All right. So initially you have a bunch of numbers scattered all over the place, right? And then what you're starting to do is you're sorting them from the top to bottom. So that's another way to visualize BubbleSort. Okay? But the important thing is we're going to focus on that pretty picture, the first one, right? And I'm going to show you how to sort. So, first one is, and by the way, there's another kind of a sort. It's called merge. Is it merge? Select merge. Merge sort? I think it's merge sort. Yeah. So the merge sort, which is actually a far more efficient algorithm than the BubbleSort, does the following thing. And I have to kind of let me restart this thing fresh. So look at this. So you have a list of numbers. You're going to split it in half, and then you're going to further split each half into half, and then further split each half into half until there's no more halves left. So this is your recursion. Okay, and then when you're done splitting things, when there's nothing else to be split, then you're going to reassemble the single things into a group of two, but in the correct order, right? So the smaller one goes on the left, the bigger one goes to the right, right? So that is basically, so we used recursion to split this thing into halves, go all the way down, and then we're coming back. This is basically your print. So instead of a print, this is where we have, okay, if the left piece goes in the correct order, the right piece goes into correct order. So what turns out to be is that this algorithm has this efficiency. So the way we measure efficiency of algorithms, or how fast something compares, how fast something runs compared to something else, is using this big O notation. All right. So if you want to compare apples to apples, you want to measure how fast something runs, you don't care about how fast the computer is, you just want to measure the actual speed of the algorithm itself. And this has a speed of n log n. So n log n is not a very bad performance. Okay. The performance of the BubbleSort, however, was n squared. All right. I don't know if it's in here somewhere. Yeah, right here. So n squared is actually one of the slowest possible, efficiencies that you can have in an algorithm. Okay, so just so you know, even though sometimes it's simpler, more intuitive to solve something using a loop, there are some problems like the merge sort, for example, that are very hard to solve with regular loops. I challenge you to try to do it and see how hard it is, right? But it's infinitely more simpler than to solve it with a recursion than it is to be solved with a loop. So even though generally speaking, if you have the choice to use recursion, you should try to avoid it because it's slower, because you can only do recursion so many times. But there are some problems that are just easier solved with recursion, a lot easier solved with recursion than they are with regular loops. Okay, so what I'm going to do now is I'm going to show you bubble sort. So before I do the bubble sort, I want to show you how to do the swapping things. So remember how we have two values, one on the left, one on the right? So let's say I have A, yeah, sure. Let's go with it. All right, let's go X is equal to 8, and then Y is equal to 6. Okay? So you basically have this kind of a situation. You have an 8, and then you have a 6, right? And then you want to ask yourself, we're going to do that thing like, is the left bigger than the right? Right? So we're going to do if my X is bigger than my Y, then I need to swap them. Okay? So help me. How am I going to swap these values? Any ideas? If I do this, if I say X is equal to Y, what happens? I have X is equal to 6, and I have Y is equal to 6, and I lost my 8. Right? And similarly, if I was to go in there and I do, okay, well, I don't want to lose my 8, then I can say, okay, well, all right, Y is equal to X. But then what happens is my Y is equal to 8, and my X is equal to 8. So they're both 8. Now I lost my 6. So how can I swap? What I'm going for is, right, I want to swap. Right? So my goal is this. I want to swap so that X is equal to 6 and Y is equal to 8. Right? I reverse it or switch their values. What can I do?
Can I do a recursive?
We don't have to do any recursions or anything like that. What I need is I need to have an extra variable where I can store some of these values, right? Or one of these values. So I'm just going to do this. I'm going to say, all right, temp. All right, so basically here, making one variable equal to the other makes you lose one of the values, right? We agree with this, like I just showed you. So what I need to do is, I want to do this, and what I'm going to do is, I'm going to make a temp variable to store the value that I will lose. Right? So which one do you want to do? Do you want to do X is equal to Y or Y is equal to X? You tell me. Because X equal to Y. Okay. So if I'm going to say X is equal to Y, I'm going to lose the value of X, right? So in this case, I lost the 8, correct? So what I'm going to do is, before I do this, right? So you said you want to do this. I'm happy with that. But before I lose my 8, I'm going to store this thing inside the temp. Okay, so at this point, temp is equal to 8, right? Then I say Y is equal to X. X is equal to Y. So now X is equal to 6, and Y is equal to 8. Oops, sorry, 6. Right? They're both 6. And then what I do to reverse the values? One more step. Y is equal to temp. Well, hold on. X is equal to, they're both 6. X is equal to 6. Oh yeah, Y is equal to temp. Yeah, correct. Okay, so as soon as I do this, Y is equal to 8, and X is equal to 6. No, not necessarily. I can do it another way. So this is one way to do it, right? You agree with this part? Okay, so I can do it this way. But I can also do it another way. So this is one way. I can also say, okay, well, temp is equal to y, right? So now temp is equal to 6. Then I'm going to say y is equal to x. So now y is equal to, what was my y? 8. And x is equal to 8, yes? And then I'm going to say x is equal to temp. And now my x is equal to 6, and my y is equal to 8. I swapped again. Okay, so I'm just storing one of these values. So I can do this, or I can do this. Just before I do it, I have to make sure that I make temp equal to the value that I'm going to lose. And then swap's done.
This is like going one
What's that?
by one. This is like going one by one.
What?
Each of the codes.
Yeah, it's going one by one. Okay, so this is just this is a baby step 1. I'm just showing you how to swap two values. Yes, we agree on this. All right. So this is not a bubble sort, right? This is just swapping values, right? So I'm gonna say this is first part is showing you how to swap values. Yes. Okay. The next thing I'm going to do is I am going to go and I'm going to make a list, right? I'm going to say A equals, and I'm going to have 4, 3, 2, 1. All right? Is that how it works? Print. Make sure this thing works. A equals A. Yeah, there you go. So there's my A. What I want to do is I want this thing sorted. Want this sorted in ascending order, so that A equals 1, 2, 3, 4. Right? That's what we want to do. So that's going to be your bubble sort. Okay. So we're going to apply the thing that we did on top. Right? So quick review if you forgot it. We had index, and the index values were 0, 1, 2, 3, right? So if I wanted to show you elements is first, right? So first element, print A0 equals, and quotes in there. All right, so A0 is this, and I can do the same thing with the other one. Let's do the second one. Just to refresh your memory real quick. Alright, so we can see the 4 and the 3, right? Okay, so now next thing I'm going to do is I'm going to do the same thing that I did here. So I'm going to go in there, I'm going to say, okay, well, if left is greater than the right one, right? So I'm going to say if A0 is greater than A1, then I'm going to do the swap. Then I'm going to do temp is equal to A0, right? Then I'm going to say A0 is equal to A1, and then I'm going to say A1 is equal to temp. Yes? Believe it? Okay. So if you don't believe it, let's show this thing again. See what happens to it. And we moved it. Okay? So now we're going to do, so this is, we compared these first two, right? We compared index 0 and index 1. So now what I'm going to do is, so this here, just let's keep track of it, right? This became 3, 4, 2, 1, yes? So now the next thing that I'm going to do is I'm going to compare these two. All right, and again, if you want to, remember your indexes, right? Index, this is 0, 1, 2, 3. Okay, so now I'm going to be comparing these two. I'm going to be comparing the 1 and the 2. So I'm just going to grab this whole thing here, right? So now I'm comparing these two, the 4 and the 2, which is indexes 1 and 2. So the easiest thing to do is I'm going to change the 1 to 2 here, 2, 2, 2, and I'm going to change my 0 to 1, 1, 1, 1. And now I'm comparing left to right. If the 4 is bigger than the 2, which it is, I'm going to swap their values. And then when I swap their values, I can go in there and do this again. And now, hopefully, the 4 should be here and the 2 should go there. You agree? And you don't have to agree, but there it is. Right? Better believe it. And then the next thing that I'm going to do is I'm going to grab this one more time, and now I'm going to do it for the last 2. Now I got to do it for these 2. Okay? And again, let's do the index real quick, just because. Alright, so now I'm comparing indexes 2 and 3. Okay? I'm going to grab this whole thing, and then I'm going to paste it in there. I'm going to change my 2 to 3 first. 2 becomes 3. The 1 becomes 2. Okay, and now when I do this, hopefully you're going to get to see that the 4 goes all the way at the end, and then the 1 is here. Okay, so this would be my first pass. Okay, so I'm going to run it one more time, see if the 4 gets to the end, and it does. Yeah? So, this is step 1. So, and I like doing this. You can, I mean, when you get to like data structures and all kinds of other, more complicated programming classes, if you get to that, you're going to have to come up with some kind of a universal solution for, I mean, right now I'm working with a set of 4 numbers, right? But I could have 1,000,000 numbers. So I don't want to go in there and, so I did this 3 times for 4 numbers. If I have 1,000,000 numbers, I have to do it, what, 999 times? No, I don't want to do that. I want to have a general solution for this. So what I'm going to do is I'm going to look at this simple little solution that I created here for some kind of a pattern. Okay, so what I'm going to say is this. So this here, maybe I'll do it this way. So this here is, I'm going to call this my I. Right? This value here. I'll call this I. Okay? And this value here, what do you want to call that one? How about I plus 1? Make sense? Okay? Alright, so I'm making a green comment so it stands out a little bit. So then, if I go down here, right, I can do the same thing here, right? This will be my I, this will be my I plus 1, right? The 1 over. Okay? And then if I do it another time in here, then same deal. Okay? This is my I, and this is my I plus 1. So, what I need to do is, the reason I'm doing this is because I need to figure out what I goes from and to. Right? So my I goes from 0. So the first value of I is equal to 0. You agree with that, right? Okay. What is my last value of I? Well, it's 2, but what is 2 in terms of how many things I have in the list? So let me do this. I'm going to say L, well, let's just do this. Print, no, I'll have to do it after. I'm going to do it right under. So print len of A, what is this equal to? Ln of A equals what? How many things are in the list? 4. Well, that's what this is. 4. Okay? So what can I say about this? I can say that this value here, 2, is equal to this minus 2. Right? Easy enough? So this one here, so I is equal to len of A minus 2. Alright? And why did I do this? Because now I don't care how many things are in the list. Right? Now I can make a list of 1,000,000, and then this thing is automatically going to stop at len of A, or 1,000,000 minus 2, which is what I want. But I'm not done. What I really want to do is I want to get these, and I'm going to put them in a loop. Right? In fact, maybe I shouldn't have chosen this. So let me put it back. So this is my I plus 1. Because I'm going to have to comment all this stuff out. Alright. That was a good idea for a little bit. Okay. I is equal to 2 is equal to this. Okay. Alright, so now the next thing I'm going to do is I'm just going to comment all this stuff out. So this was just me going through the motion to figure out the pattern, right? Because I'm not smart enough to see the pattern in my head, right? Well, I'm going to just start with a simple little problem for a list of 4, and I'm going to move the biggest value all the way to the right, which is what I did. And then I have to figure out, okay, well, what is this value equal to? Well, this value is going to be equal to I, which starts at 0. It will always start at 0 for any size list. And then it goes to 2. Well, 2 can be summarized as the length of the list minus 2. Okay? So now what I'm going to do is next step, I am just going to do, I'm going to comment out these for now. So they're not going to show correctly yet. So what I'm going to do is I'm going to make a loop for I in range from 0 to, let's go len of A, right? And again, this is, you don't have to solve it right on the first try. Run it, see how it works, and if it doesn't, adjust. Okay, I'm going to go and print my I, and I is equal to, let's see what. So I'm expecting to see values. What values am I going to see for I here? I'm going to get 0, I'm going to get 1, what else? Two, right? Is it going to show a 3? Find out. It does. I don't want it to go to 3, right? So what do? I wanted to stop at a 2. How do I make it go to 2 only? How about I just subtract 1? Sounds good. Run it again. Does it go to 2? Yep. Okay. So now I generated the I that I wanted to, right? Okay. Then next step. And again, remember, it's not, this is not rocket science. If you can test it, you can see if it works, and if it doesn't work, you can just make a small little adjustment, and now it works to the way you want it. Okay. So what I'm going to do now is, all right, I know I'm commenting out this piece of code because I know it works, right? I know this worked. So now what I'm going to do is I'm going to grab this stuff, this here. I'm just going to copy it, paste it. Let me fix my indentation on this. All right? And what did I say? I said this is going to be I. So the 0 is I. And the 1 is I plus 1. I plus 1. I plus 1. Right? That seem right to you? Hopefully. And now when I comment this piece of code out, this loop is supposed to generate the same result that I did as, copy pasting this thing 3 times. Okay? Run it. There you go. Okay, so that was the first pass. So this was when you looked at the picture and it was comparing left to right, and it moved the 8 all the way to the right. That's this loop right here, right? So this loop here is to loop to move the biggest number to the right, right? Okay. Well, how do you think I'm going to move the second biggest number? I want to move now the 3 all the way 1 left to the of the 4. How do I do that? How about I just copy paste this thing again? I'm just going to copy this whole thing. I'm going to copy it, right? And I'm going to do the same exact thing that I did here. So I started with this, the simplest possible thing that I could think of, and then I repeated it a couple of times until I got what I wanted. Now I know that this can be summarized with this loop. right? So this loop moves the biggest number to the right. Well, why don't I just grab this, right? I'm going to grab this thing. I'm going to paste it right there. Now what do you think is going to happen?
The biggest to the right.
It's going to move the 3 somewhere in here, right? Hopefully. So if the first one was we started with, right? So before the loop we had this, right? So at the end of the loop the 4 went there. So if I do the loop one more time, now what's going to happen is the 3 is supposed to land over here somewhere. The other 2 to the left of it, who cares? Let's just run the program and see if it moves the 3. Yeah. Okay. Why don't I do it one more time? I'm going to grab this thing now, copy it, paste it one more time. Right? So this was, we had a 2, 1, 2, 1, 3, right? Okay, so the next thing that I'm going to do is do it one more time. Actually, 3, 2, 1, 4. That was this one here. That was this one. Right? So now this one here is supposed to be, the 2 is going to get moved where the 1 is, which is pretty much now we sorted the thing. Hopefully. Alright, I run it again. And now it's sorted. Okay? But, just like I did before, I don't want to go and copy paste this thing 3 times. I had to do this thing 3 times for 4 numbers, right? So it's actually the same relationship as this. So I had to do this for 4 numbers, right? For 4 numbers, I had to do this piece here 3 times. And again, for 4 numbers, I had to do this piece here 3 times. So that means that this loop is going to happen as many times as this loop, right? So I can just copy this. I'm going to comment this out, all right? And then I'm going to grab one of this, throw it in there, and then I'm going to make another loop for j in range that's going to happen as many times as this other one. -1, steps of 1, right? So this loop repeats the inner loop that many times. Okay, so now it's your nested loop, and then I can print the A, and then hopefully, if everything's right, if I didn't mess something up, then I should have a sorted list at the end of it. And I do. Okay? And this is your BubbleSort. Okay? BubbleSort. I can actually make this a little more efficient because I don't have to go all the way to the end every time, because remember, when you move the 8 all the way to the end, you don't have to go and try to move the 7 all the way to the end because the 8's already there. So what I'm trying to say is that the inner loop can happen one less time every time as you move these numbers. But we're not going to do that. I'm going to just keep it as simple as possible. Okay, this is good enough. So this is your BubbleSort. So I expect you to know how to do the BubbleSort. Python has built-in functions to sort things for you. You don't get to use them. Okay, there's a sort, there's a max, there's a min, there's a sum, there's all kinds of different things you can do with the functions that are already built into Python. But I want you to know how to build those functions yourself and how it works. Okay, so this is your BubbleSort. What are you going to use this for? Well, we have a bunch of coding bat assignments in here. There's a whole lot of them, actually, it looks like. Okay, but don't worry, coding bat is not too bad. Let me tell you, first of all, so that's pretty much all I want to tell you as far as this week's topic. Now I'm going to show you how to use coding bat. Okay, but before I get to coding bat, why don't I just go through these different assignments and see if you need any hints. So first of all, 34. You know the wonderful song of 99 beers on the wall. It goes like this: 99 bottles of beer on the wall, 99 bottles of beer, take one down, pass it around, 98 bottles of beer on the wall. Okay, you're going to write this song recursively. Okay? That means no loop, no for loop, no while loop. You're going to have a function like the one that I showed you, the recursive one, that is going to repeat this thing over and over and over again until it gets to the end where there's no more bottles, and then you give it the final verse, which is no more bottles of beer on the wall, no more bottles of beer, go to the store, buy some more, and now it goes back to 99. But that's where it stops. Okay? So that's a recursive program. Now we're going to the next one, coding bat. Coding bat is a way for you to write programs and have the web page test if the programs are working for you. Okay? So let's go to that first one. So first one is, I'll show you how this works. So this is coding bat, right? And in here we're giving some kind of a problem, right? So in this particular problem is when squirrels get together for a party, they like to have cigars. A squirrel party is successful when the number of cigars is between 40 and 60 inclusive, unless it is a weekend, in which case there's no upper bound on the number of cigars. Return true if the party with the given value is successful, or false otherwise. Okay? And this is how these real world problems are going to be. You're going to be given some whatever, some kind of a problem, a bunch of text, and maybe not even the text, you have to come up with the text and the actual problem, and then you have to solve it. Okay, so a lot of times I kind of hold your hand and I tell you, okay, this is what's expected of you, but now we're getting more into the real world, so less holding your hand. So here's what we have. We have this problem, right? So the idea is this: if this number here is between 40 and 60, the function is going to return true, no matter what. Okay, but if this argument here is true, then the number needs to be only greater than 40. So if this is false, this value needs to be between 40 and 60. If this is true, this value just needs to be greater than 40. Got it? Okay, so how would we write this? Well, I'm going to use both of these. So this is how the function is expected to work, right? With these arguments. This is just like, your guide in the beginning. This is my function definition. So these are the variables that I'm going to work with. One is called cigars, the other one is called weekend, right? Cigars is this number, and is weekend is this number. Okay? Then what do I do? Okay, so first of all, tab doesn't work here. Oh, now it does. They fixed it. Didn't used to. Very nice. All right, so print doesn't work here. So you cannot use print hello or whatever. This is print is not going to work in coding bat. So don't try it. If you want to, you could write your program inside idle, test it with prints if you want, and then remove the prints and throw it back into the coding bat to see if it works. Okay? So let me do this. And by the way, there's a hint, since this is the first one, so it will actually show you the solution, maybe. Who cares? I'll solve it for you. So cigar party, cigars. So we said that if my cigars are greater than 40 or equal, right? And my cigars are less than or equal to 60, then this is a good party or whatever. Return true. Yes? Unless we have is weekend, which is true. So if we have is weekend, which is equal to true, and my cigars are greater than or equal to 40, that is also our successful party. What's left? Well, I got to return false. So if it's not a successful party, then I can just say, okay, well, return false. Right? And now what you're going to do is you hit the go button, and if the function works, you get a green light on everything, and good job. Okay, so what you have to do is, for each one of these problems, I want you to take a picture of this. Alright, grab that whole thing, take a picture, put it in like a Word file or something, if I have it. Somebody was asking me questions about this stuff. Alright, throw it in a Word file, and then get all this, just the code, and put it in a big file. right? This is assignment, whatever, 35, right? So I can say P35 coding bat, throw that stuff in there, right? That's the actual code. So what you're going to submit is you're going to submit one file that has the code, and then you're going to submit another file which has the pictures that are showing me that this worked. Okay? So it makes my life easier. So how do I grade this? I look at the picture, yes, I see it's all green, you get an A. Okay? And be sure that you're using only things that we have learned in this class. Okay? Any built-in functions that sort the thing for you, find the min, the max, and whatever, you don't get to use. Okay? Only things we learned. Okay? Just the basics. Ifs and elses and for loops, and that should do the magic. Okay? So that's an example of coding that. Okay? And there's some other ones. There's like count evens. Right? Count evens. Let's do that one too. Okay? So return the number of even ins in a given array. Blah blah blah. Okay, great. So how do we check to see if a number is this the number of even ints? Okay, so we're counting them, right? So I'm going to have some kind of a count. Make that equal to 0. I'm going to make a loop that goes through my list. And by the way, Python also has a count. You don't get to use that either. Okay? So we're going to just say for I in range from 0 to the length of nums, steps of 1, right? What is this going to show me? Well, we can do if my nums I, which is every element, modulus 2 equals 0. We did one of those, checking if number is odd or even. Then I'm going to count it. Count plus equals 1. That's it. And then return count. Okay? Hit the go button. If it works, it works. And if it doesn't, maybe you messed something up. Like 10. Won't work most likely. Okay? So that's it. You just keep running this thing until you get all your tests to be green. If for some reason you can't make the other tests to go green, that's okay. I don't care. Okay? Because you can only test the thing based on where it fails, and you cannot possibly test it if you don't know where it fails. Okay? So if we knew where it fails, which are all these different tests here, and you get those to work, I'm happy. The other tests, maybe for 1 or 2 assignments, you might not be able to get the other tests to work. That's okay. Okay? So that's how we're going to do the coding bat, right? So when you're done with this piece, you grab the thing, you take a picture, you throw it in the Word, right? After that first one, right? Then go to the code, grab this, alright, and that's your next one, and throw that in there. Okay? So and then you submit this file with all the actual code with the actual screenshot showing the thing worked. Okay, and you shouldn't show me a screenshot where the thing doesn't work, right? Not a good idea, because you're not going to get any points for it. If I don't see the screenshot, you're not going to get points for it anyway, so make sure it works. Any questions about coding bat? Again, do not use print in here. If I try to do, print count equals count. It's just the way this web page is designed, you're not allowed to use print in it. Okay, the web page runs the program, tests to see if it works, all that good stuff. Okay, and I'm actually writing software, it's almost done, similar to this web page, which is going to allow me to automatically grade all my assignments. So that's coming in the future, but you don't care about that. Okay, so yeah, in the future I'll have students just upload all their files to my web page. The web page grades it automatically, places a grade, and I can just sit home and watch TV or whatever. Okay, so yeah, that's why you want to take programming, because it saves work. Anyway, so that's that. That's coding bat. So that's the first one. Lists and logic. There's a bunch of those. Then there's the next one, coding back strings. Okay. A couple of these I made extra credit. So this one is an extra credit. The other one is also an extra credit. Okay. If you want to do them, I'll give you extra points. If you don't do them, no big deal. But yeah, these two are the most challenging of all of them, which is why I made them extra credit, so you don't feel too bad about yourself. Let's do one of these from the string. So let's see, maybe I'll go times. No, you have a solution for that one, so I'm not going to look at it. You can look at that yourself. That's your freebie. Combo string. Okay, let's look at that one real quick. So this is 36, right? Given two strings A and B, return a string of the form short plus long plus short with the shortest string on the outside. Okay? How are we going to check the length of strings? Well, using len, right? So if len of A is less than len of B, then what I'm going to do is I'm going to say return. A was on the outside, shorter. Okay, so A plus B plus A. Right? And otherwise, if, well, I guess I can just do another return here, right? Because if it's not going to be this case, then it's going to be the other way. Return this time B plus A plus B. Right? Keep your fingers crossed. And there you go, it works. Okay, so they're not hard. They're really not that hard. As long as you understand what's going on and how you're supposed to approach this, no problem. Okay? But I did have one student kind of freak out on me on this, but don't worry. All right, coding bad is not too bad. If you get stuck on this, let me know. Come to me, I'll help you out. Okay? So it's just more practice of mental gymnastics. Next one, 37, sorting and arrays. Okay, and then I think I have it on all these other ones also. No, I don't. So you don't need a whole lot of this. You can't really use anything to aid you on that one. You have to write it. Count evens. So let me just do this. You're not allowed to use any built-in functions. Okay. So I'm going to copy this, throw it in. That one you can't really do anything with it. Okay, so I'm going to edit this here. And this is your hint. You may not use any of these functions. Alright, min, sum, max, sort, sorted, reduced, count. You also don't get to use count. Yeah, or any other built-in Python functions other than, I don't know, range, right? Because you need that for the for in range, right? That's it. You don't get to use anything else. Okay? So that's that. And those are the coding bats. 35, 36, 37. Real quick. Centered average. Okay, so just so you know, just let me give you a hint on this one. This one here asks you to find the centered average of array events. Array is basically a list. Okay? If there are multiple copies, so what you're going to do is this. You're supposed to find the average of the numbers in the middle. You're going to ignore the first, and you're going to ignore the last. Okay, well, after you sort the thing. Okay, so these here, all these examples in here appear to be sorted. They are sorted, but you're not given really a sorted array. The assumption is you're going to have to sort the thing first. After you sort it, you exclude the first and the last. Actually, this one isn't sorted, right? You have to take the average of everything in the middle. Okay, so this one is actually no, they're not sorted. Only the first one was sorted. Okay, so the average of just the first, of only the numbers in the middle. So what you have to do is sort the thing first, then make a loop that goes for, where is it? For I in range from 1, don't start it at 0, to the length of nums minus 1, because you don't want to include the last one, right? So I'm telling this loop to go from the second to 1 before the last in steps of 1. Okay? And then you just sum up the whole thing. Sum is equal to 0. Sum plus equals nums I, right? But before you do this magic, sort nums first using BubbleSort. Okay? Again, you don't get to use sort. You gotta sort it. Okay? And I showed you the BubbleSort. That was the point of this exercise. So you can just literally grab this thing here, throw it in there, right? Change instead of nums, and instead of a, put nums. All right, and hopefully it works. All right, wherever you see a, nums. And I think there was some kind of an issue with this particular exercise, just so you know. Let me just test it. Because I tested it the other day and it wasn't working. And it wasn't working not because my solution wasn't good, but it's because I don't have a return sum. What don't you like? Num is not defined. Not nums. Go. Yeah, this one is actually, that's the one that's not really working. Okay? And the reason for that is because in here, look at this one here, right? We're supposed to return the centered average excluding the first and the last. Well, when you add these here, 2 plus 3 plus 4 is 9, which is what I want, not 3, which is what it's expecting. So this one's actually not working, FYI. Okay, so if you hit the wall on this one and it's not working, is it because the coding bad, the web page broke or something? Okay, it used to work in all these other semesters I've taught the class, but all of a sudden now it doesn't. Okay, but it's not here. But now you have the solution for this too, again. Okay, yeah, sum 13, big diff, right? So they're a little bit more challenging, these sum 13, big diff, especially sum 13 maybe. So that's that. So now you know about recursion, you know about BubbleSort, you know about decoding that, and you get to do what you get to do. Any questions?
Not related to this, group 7, midterm, what are we gonna have?
Midterm is a take-home. It's a take-home deal. You don't have to worry about it. Midterm is, I'll review it next week, right? But the midterm is just going to be, there's going to be a multiple choice. There's going to be, write a few programs.
Coding of this type, right?
Yeah,
Recursion?
yeah, maybe even easier. Yeah, so, but for the midterm, you need to know functions, you need to know the ifs and the elses, the loops. I'm not going to do any recursion for the midterm, but everything except recursion, basically. Okay, and lists, those good things. After that, after the midterm, we'll do files, and then a lot of it is extra credit. So these last, few weeks, pretty much the whole last month, is extra credit. Right? Don't use it as an excuse not to do the assignments, because these are actually the most fun. And the way I have set it up is that if you want to do all the extra credit assignments, you can skip the final exam. Right? So if you don't want to do the final, do all the extra credits, and you don't have to worry about the final. But it will actually be easier to do the final than all the extra credits. But if you really want to learn, I even have localization in there, so that which is basically how you're going to get to your programs that you have already written to show in a different language, without you going in there and rewriting the whole code.
Do we have class during the Thanksgiving?
I don't know. Thanksgiving. When is Thanksgiving?
November.
Is it November? No, I don't think we're going to have a class on that day. So the week of November 23rd, so that will be one of these extra credits. Yeah, it'll fall in this week. So yeah, we're not going to have a class, but you still get to do the work. Yeah, it's extra credit anyway. Okay, so there you go. That's all I have for today. If you
For interest training class, we're not going to have class.
No, we're going to have class for the extra credit meetings, except the Thanksgiving. unless you want to pay me extra. But no, the campus is going to be closed. We can't make it here. Okay, or the sheriff will do something about it, maybe. So that's it. I'll post the video. Let me know if you have any questions. Don't freak out. All right, if you need help, just let me know.